Hello. So today we are going to learn about an interesting topic called closures in Python. So a closure, it is a function that has access to the variables from the scope of outer function in which it is defined, even after the outer function has completed its execution. So a closure, it basically has three different components. The first one is the outer function. Then we have some variables that are defined in this outer function, and then we have a inner function. Okay, so here is a basic example. We have this outer function, right? I just named this to outer, and then we have a count variable which is defined, right? Inside this, I'm increasing the font size. Okay, so the three components are, firstly, we have the outer function that basically wraps everything inside. Then we have variables which are declared inside this outer function, and after that we have the inner function, right? The inner function uses the variables which are defined inside outer function. Okay, in this particular example we are then returning the inner function. Why we are returning the inner function? Because we will be using the inner function to get access to count. This function is basically defining a count variable, and then every time we are calling this inner function, it is just incrementing the count value by 1, and then it is returning the count. Since through this outer function we need access to the count, we will need this inner function, right? So now let's copy this function, and I will create a new code block. Okay, here I will run this code. Okay, so now I have a outer function defined, and there I can run this, right? So the outer function, what it should return? Within the outer function, I have a return statement that is returning the inner function at the bottom. So the outer function, it should return the inner function, right? I can do underscore underscore name underscore underscore to print the name of this particular function. So if I run this, I can say it prints inner. That means the outer function is returning the inner function. Okay. So this is actually returning a function, and the job of the function is to give me the count. Okay. So I'll just name it to get counter. Okay. And then I'll run this code block. So I have access to the get counter function. Now in the next code block, I'm going to use this get counter to get value of count variable, right? So if I run it once, then from the code, I can say that here the count variable has a value of 0, and every time I'm calling the inner function, it is getting incremented by 1. So if it was initially 0, then it was incremented, and then the count was returned by the inner function, then I can say that here the value should be 1, that is expected. But what if I run this again? Now this time it is 2. If I run it again, I can see it is 3, 4, 5. So this means this value is not getting set to 0. The count value is not getting set to 0. This variable is still getting persisted across different function calls. So the inner function, I'm calling it multiple times, and it has access to this count variable. And we know that the outer function in this particular line, it has finished its execution, because here when the outer function has finished its execution, it is returning the inner function, but the inner function still has access to the variables which were defined in the outer function, which is count in this case. So this is what exactly closures are. Closures are basically providing you access to the variables which are defined in this outer function, even though its execution has been completed, which we can see over here. Okay, so now what we can do is we can have a look at other things as well. For example, within this get counter function, I can do underscore underscore code underscore underscore dot co underscore free vars. Okay, so what it is going to do is it is going to print the variables which are part of the closure. For example, count is the variable which is getting remembered, right, from this get counter function. So now this was a really simple example. We can move ahead and see some more interesting examples. First, let's just disable the AI so that I'm not getting interrupted by this. Okay, so let's create a simple example of closures. And this time what we are going to do, we are going to implement get multiplier functionality, right? So the get multiplier functionality, what it is going to be, basically we are going to have a function, and the function is going to give us another function, and the another function which take any number as input and return uh, the multiplier by some certain number. For example, let's say here we can have declare it as nth multiplier, right? We can take n as an argument, and then we can have inner method, and let's just call it inner only, right? It takes any number x and then it just returns x into n. Okay, so that is all we want. We also want to return the inner function because this is the one that we will be using to pass any number and get its multiplier, right? So now here we can define multiply by 3 function, and this is nothing but nth multiplier with n equals to 3. Similarly, we can have similarly we can have another multiplier as well, right? And this is, let's say, multiply by 10. Now we can say that here in the nth multiplier we provided this value which is 3, and this has finished its execution, and that is why we got this return statement, which is basically nothing but a function. But even when I use this function and I provided some input which is x, right? So let's just provide x as 10 for the first call, and we also want to print this. Now let's again call this, but this time let's, instead of 10 we will print 15. Okay, let's have two more statements which basically prints the multiply by 10 with the same input. Okay, so we have total 4 function calls, and the first function is basically created by the nth multiplier with argument 3, and the second function is created by the nth multiplier with argument as 10 over here. Okay, so we can create family of related functions using this closure closure thing. Okay, so let's just run this. And here we can say that everything is getting printed as expected. 3 multiplied by 10 is 30, and 3 multiplied by 15 is 45. Similarly, it is 100 and 150 when 10 and 15 are multiplied by 10. Okay, so here this method multiply by 3, it remembers that it has to multiply 10 by 3, which was actually provided as an argument to the outer function. So that was declared within the scope of outer function. Still, it is getting persisted, right, by the inner function across multiple function calls. Okay, so let's move ahead, and we can have another example. This time we are going to make something practical. So we can use this because across different function calls, we know that the variables are actually shared, which are defined in outer function. We can use it to share state, and what that can be used for is basically we can use it for something like caching. For example, here we have, let's say, API fetcher, and the API fetcher, this will do nothing but this will have a simple method called fetch, right? And this will take URL. So the thing is, we can use this for fetching different responses provided by the URL. So we will use request module, and within this request module, what we are going to do, we are going to use request.get, and we will simply pass the URL to it, and this will return some response, right? So what we are going to do is we want to return the same response from the fetch request, right? So we can return the response, and finally within this outer function, which is the API fetcher, I want to return this inner function, which is nothing but fetch. Okay, so this is a really simple example, but the benefit that I can see is because I know this closure will have variables that can be shared across multiple function calls. So why not use it to cache some response to URL so that I'm not making redundant request. So what I can do is I can have something like cached responses. Okay, and here I can see if URL is not in cache responses, then what I can do, I can add it to the cache responses, right? I will use the URL as key and then I will store the response. Okay, so that is basically this thing, request.get URL. Okay, so now it is there, even if it was not already there in the cache response. Finally, what I can do, I can return the cache response for the key of URL. So now what I can also do is I can also have some print statement so that we know whether this query that we are making, is it getting cached or are we making fresh API request. So if URL is not in cache response, this then we are making a fresh request. So nothing cached, making API request to then the URL. Okay, and similarly in the else statement, when we know that we are not making a request, then I can say, I can copy this and I can simply say that cached API request to URL and then the particular URL. Okay, so let's run this code and now let's start using this fetcher. So I can call it my API fetcher, right? And this will be nothing but the API fetcher call. So this will be my API fetcher, and then I can use my API fetcher for making multiple API requests. For example, let's say I make API request to www.google.com, right? So then what I can do, I can then print the text component on it, right? Because it's a HTTP get request. So the get request has a text method on it, or the text attribute actually. So I also want to print this response. Okay, so then I can make a redundant request to the same URL, right? So then let's make request to another URL, which is for let's say example.com. Okay, and then another request to the same URL. Okay, let's run this code block, and here we are seeing that there is some issue. Okay, so no schemes applied, URL www.google.com. So the issue is basically you have to prefix this with HTTPS. Okay, and I will add this to all the URLs, and now it should be working. So it says nothing cache making API request to www.google.com, right? And then I can see it has this particular response. Then it says cache API request to URL www.example.com, and looks like there is a, it is hard to see these things. So what I will do instead is I want to make sure that I'm making these separately. Okay, firstly I will clear the cell output, and then another code block I will use, and from here I will be making the request one by one. So let's run this. So it says cached text request to URL. Okay, if I run this again, I'm getting the same thing, cache API request to the URL. So it is again and again getting cached, right? So if I use something new, for example www.youtube.com, then I can say it says nothing cache making new API request to this particular URL. If I run this again, this time it says cache API request to this particular URL. So this way, using closures, we implemented our own API fetcher, which has the support for caching through this shared cache responses across all function calls. Okay. One thing to keep in mind is that for different fetch functions that I'm getting, it is actually using the same cache response. But suppose if I am making another API fetcher, let's just use another code block, and over there, I'm going to define this. So I'm creating API fetcher 2, and I'm again using my this API fetcher closure, and let's run this. Okay. So if I again go for the same URL, which is, for example, let's say www.youtube.com, which I know it is cached, right? So here I have to make the request. In this case, I can see that it says nothing cached, even though it was cached, right? So if here we have something like example.com, which I'm pretty sure is already cached, and I run this, it says cached API request. Okay, so example.com is cached. But if I'm using different API fetcher, and this time I'm providing the example.com, so it says nothing cached. The thing is, because these are different functions which are returned from my closure, they have their own cache response dictionary. Okay, so the API fetcher, it is going to just provide me with a function that is going to have its own copy of all the variables which are defined in the outer function, right? In the API fetcher. So every time I'm calling this API fetcher, it will return me a function that I know, which is the fetch function. But the fetch function will have access to this variable, right, which is cache responses. And for every fetch function that I get by calling this API fetcher, they will have their own copy of the cache responses, right? If I call the same function, which is, let's say, my API fetcher, again and again, it will maintain its copy of cache responses. But I have created, let's say, new function, which is my API fetcher 2, using the same API fetcher closure, then this will have its own different copy of the cache responses. But for every single function, if we call it multiple times, I know for sure that this will access the same its private copy of the cache responses. Therefore, if the cache response is not there, then after making the request once, it will be there. Okay, so this was something to remember. And let's come to some advanced use case. So we know that we can use it to share some state, and Python in itself, it is a programming language that supports a function with another function as argument, and a function can also return a function, as we have already seen. Okay, so what we can do is we can use it to create a function that basically takes another function as a callback and just enhances its functionality. For example, let's say I am creating a time function, and it takes another function as an argument. And what it will do, I will call the inner function as wrapper. You can call it anything. So here I'm just calling the function. Okay, so that's all I'm doing. And finally, I want to return the wrapper. Okay, so this is doing nothing, just calling the inner function, but we want to do something. Okay, so the function which is there, it can have some arguments, and we can pass the function arguments in every single function call for the inner function using star args and star star kw args. Okay, so we can pass the same thing to our function, and the function, since we are creating this generic timed function, which will basically log the total time that is taken for a function execution. Okay, so what we can do is this function, this may return something, right? So we can also record its response. Okay, so after recording or storing the response, what we can do is within the wrapper we can return this response. But the one thing that we want to do is actually also calculate the total time that is taken in the function execution. So for that we will be using the time module. Okay, so we will be using the perf counter from time module, and let's say it is start time over here, and at the bottom it will be end time, and that is again coming from perf counter. So the total duration is basically end time minus start time, and we can print time taken for execution of function, then the name of the function, which is fn, argument is available, right? So I can use uh, dot underscore underscore name underscore underscore and turn it into formatted string. So time taken for the execution of this particular function, then its name is, let's print the duration, and we can print it up to, let's say, 4 decimal points. Okay, and after printing its execution time, we are finally returning the response. Okay, so this is our time function. Let's run this code block and let's start using this time function. So it takes another function as an argument, so we need another function. Let's define another function. Let's call it sleepy, and what it basically does is basically sleeps for given time. Okay, so it can take duration as an argument. Okay, and what it will do, it will call the time dot sleep for whatever the duration that we are telling it to. Okay, so now we have our sleepy function. Okay, so I want to add the functionality to print the execution time for this sleepy function. How I can do that? Well, we know that we have the time as the outer function, and the outer function can be passed another function as an argument over here. So we will pass the sleepy, and this will return me the modified function, right? Which is nothing but the wrapper. Okay, so I will get the wrapper over here, and I will call it, let's say, time sleepy. Okay, because this sleepy also prints the timing. Okay, so we have time sleepy, and time sleepy, it can have argument duration, right? So we can set duration to be, let's say, 1.5, and then again we can use the duration to be, let's say, uh, 2.5 or something, right? And we don't only want this, but we also want to print it. Okay, so let's also print this thing, although this will not make sense because actually the sleepy function, it is not returning anything, right? So even if I remove the print statement, it won't matter. Okay, and I can just run this code block. So it says time taken for execution of sleepy function almost 1.5 seconds, right? And almost 2.5 seconds the second time it was running. And in this particular sleepy function, I see that nowhere I have written the functionality to print the time taken for its execution. So the benefit is basically I can have a bunch of different functions, and I can basically add the same time functionality, or I can also say it that I can decorate any function with the timed functionality, right? So this is the benefit, and here is another syntax that you can also use for this, right? Here what I did is basically I created a timed sleepy by passing the sleepy function to my timed closure, right? So what I can do is I can also set it like this, right? So I already have the sleepy function. Let's just copy this function. Okay, and on top of this function, I can use this syntax at the rate and then the name of the closure that I want to apply, which is actually timed, right? The name of the closure is basically the name of the outer function. So I want to apply this to the sleepy function. So internally, it is just providing the sleepy function to time function as an argument. Okay, and then I can copy the same thing over here. which is the multiple function calls, right? Here I do not have to call it as time sleepy, it is just sleepy. Okay, and let's run this code block. Okay, so it is working as expected. So this syntax also works. Now one more thing to keep in mind is I have created this sleepy function with decorator. So I know that the time function is taking the sleepy as an argument, and what is it is returning? It is returning the wrapper. Okay, so the wrapper actually has a start time counted, then the function is getting called, right? If it returns some response, then that response is stored. Finally, the end time is calculated, and then we are printing how much time it took for our function to execute. And then finally, we are returning the response from the function call, right? So that is all we are doing. So we know that this is actually the wrapper function, right? This time sleepy is now the wrapper function. And what I can see is if I do sleepy dot let's say underscore underscore name underscore underscore, then it says wrapper. So context is lost somewhere because it was sleepy function, but now it says wrapper. The reason is because here this function is getting returned from timed. Okay, so I want to still retain the name of the sleepy function, and this also has a docstring. So for debugging and other documentation purposes, I want to have docstring as well, right? So even if I look for doc underscore underscore doc, that should provide me the docstring. It returns nothing, okay? Because the wrapper, it has no docstring. So what I can do is basically I can use this particular functionality, import functools, okay? And from functools, what I can do on top of my inner function, I can define functools.wraps, and then I pass the function. So this will actually retain the context from this particular function that I'm passing as an argument to my timed closure. Let's run this code block and let's come at the bottom. Here, if I let's say define the sleepy function now, I rerun this code block. Okay, so the sleepy function is again defined. Now, if I print the underscore underscore doc, I'm getting the underscore the actual doc string. And if I do underscore underscore name, then I'm getting sleepy. So I'm still preserving the context. So this was all about closure, and I hope you liked it.